So we're gonna go through question 7, November 2018 for grade 10 chemistry. So now they say a group of learners prepare 0.25 mol per liter solution of sodium carbonate, because we know that cubic decimeter is 1 liter, by dissolving a 12.2 gram sample of hydrated sodium carbonate in 200 cubic centimeters of water. So first thing first, we write down our units and we write them we convert them to their SI units. So the concentration of NaCO2, Na2CO3 is gonna be 0.25. But they already gave us like in its they already gave it to us in its SI unit, so it's 0.25 per mole per cubic decimeter. So also our mass is given in grams, so the mass is fine. So 14.2 grams. And now we have our volume of water, which is actually the volume of the solution. It's gonna be 200, because it's gonna dissolve. When it dissolves, the volume doesn't increase. It's gonna stay the same. So 200, you're gonna divide it by 1,000. 1, 2, 3, which is gonna give you. Sorry, man. Someone's knocking on my door.
Okay.
What's this thing? Let me just mute this for a bit. The recording. So we're gonna have it we're gonna convert it to 0.2 cubic decimeters. And then now they say, what's the meaning of the term hydrated? That just means something is in water. Easy. But like that's why I don't want to go that deep into definitions, because some of them are very easy. Some of them you're gonna have to like memorize them by yourself, because even if I give it to you in an exam situation, you're gonna need to like know the definition. So they say write down a balanced chemical equation to show how the calcium carbonate is going to be dissociated. So when they say it's going to be dissociated, that means it's going to split into its ions. So you're going to have something like Na 2 CO3 plus water. Sometimes it's not even necessary for you to write the water, but let me just write it in this particular case. Then you're gonna have 2Na plus, because sodium has an oxidation state of 1 plus, but it's gonna be 2 to balance this side. Then you're gonna have CO3 minus. I think this is the correct one, but here it's gonna be 2 minus 2. So yeah, this is the correct one, because because for carbon dioxide is neutral, and when you add another oxygen, that means it's gonna have two additional electrons. So that's why the charge is 2 minus. So if you want, you can still place the water there, but it's not always necessary. And then now they say the learners then take 10 cubic centimeters. Let me just erase this. So now we have our additional units. Let me just write it in text. So they take 10 cubic centimeters of a prepared solution, and allow it to react completely with 5 cubic centimeters of diluted hydrochloric acid, according to the following balanced equation. Now they want you to define a mole of a substance. So you can just define that. And they say what type of reaction is represented by the chemical equation above. This is an acid-based reaction, because sodium carbonate is a base and hydrochloric acid is an acid. So do you understand that? So like to convert the cubic centimeters, like I also wanted to convert them first, but you just divide them by 1,000.
Yeah.
So they say calculate the number of moles of hydrochloric acid in the 5 cubic centimeters of hydrochloric acid if its concentration is 1. So you know that your concentration is equal to your number of moles divided by volume.
VM.
So they want you to find your N. They give you a volume is 5 cubic centimeters. The concentration is 1. So you're gonna have N is equal to CV. Then you're gonna have your 1 being multiplied by 5 divided by 1000. So we're gonna get our number of moles. So 5 over 1000. I think that's gonna be like 5 times 10 to the exponent negative 3, or 1 over 200. But using my calculator, it says 5 times 10 to the exponent negative 3 mole. Then after that, they say calculate the mass of sodium chloride, which is formed in the reaction in 7.3. So they want you to find the mass of sodium chloride. You have your number of moles of hydrochloric acid. You have your number of moles, you have your sodium chloride. So you can relate these two. So the number of moles is 5 times 10 to the exponent negative 3. So now this is the part like let me just erase everything there. So now you're gonna have your sodium chloride. So first you're gonna relate the HCl to your sodium chloride. So the ratio is 2:2. So it's 5 times 10 to the exponent negative 3. Negative 3. Then this is gonna be X. So since it's 2:2, it's gonna be 1:1. So basically, this is the number of moles of sodium, because it's basically 1:1. So the number of moles of sodium chloride is equal to the number of moles of hydrochloric acid that I used. So now they want us to find the mass. So you know that your number of moles is equal to the mass divided by the molar mass. I don't know. You guys might be writing MW, but I might write MW or MM or just capital letter M. So you know, so from this equation, you can derive that your mass is equal to the number of moles multiplied by the molar mass. So now you just have to substitute. So that's going to be like 5 times 10 to the exponent negative 3. So do you have a periodic table with you?
Yeah.
Yeah, so can you get like the molar mass of sodium chloride? So that's gonna be chloride
sodium
is 5.5 and sodium is 33. Sorry?
That is gonna be 58.5.
Okay. So Here you're gonna have your 58.5. So let me just calculate this. 58.5. So your mass is gonna be 0.29 grams. Did you get the same answer?
Yeah.
So that's gonna be the mass of sodium chloride that's gonna be formed. So, like, just from the looks of it, like stoichiometry isn't that
Not bad.
difficult, but it is that difficult, you know, like it's tricky.
Yeah.
But once you get used to it, like it's a very simple concept to understand.